Welcome to Terra's Third Thursday video podcast for the month of May 2025. Today, we will be having another strategic discussion designed to help your organization maximize your e-scrap and or ITAD operations. I am your co-host, Stephen Napoli, president of TERRA, the Electronics Reuse and Recycling Alliance. For our regular consumers of these sessions, you know that we strive to be brief and to the point while providing you with useful information to enhance your knowledge, operations, and bottom line. As a reminder, all of our previous content is available on our website, jointerra.org. But quickly before we get started, we would like to acknowledge our new and returning members since our last session. These organizations include Next Tech Partners, AmpleTech Refresh, A Better Way Computer Recycling, Liquid Technology, Chip Sales, Blue Whale Materials, Early Upgrade, Crown Industries, and Peregrine. Today, I am pleased to welcome Sean Grixti with Cyclic Materials as our host. Cyclic Materials has developed a proprietary two-phase process that transforms yesterday's waste into tomorrow's critical materials. They are creating a circular supply chain for the rare earth elements and critical minerals that power our global economy, without compromising quality or environmental impact. I know you'll enjoy listening to our session. From tech waste to treasure, earn profits from rare earth elements. At the end of today's session, please stay tuned for a brief 90-second infomercial about Cyclic Materials and their proprietary process. Enjoy the show. Hello, and welcome again to another edition of Terra's Third Thursday webinars. This month, we are pleased to have Sean Grixti with us from Cyclic Materials, and we're going to be investigating rare earth materials, rare earth elements, and be talking about how you, as certified recyclers, could potentially earn profits from these materials. So again, Sean, would you please introduce yourself and tell us a little bit about Cyclic Materials also?
Yeah, sure thing. So my name's Sean Grixti. As mentioned, I'm the Director of Circular Partnerships at Cyclic Materials. I focus on sourcing rare earth bearing waste streams from electronic scrap into our recycling facilities. And then I also look to reintegrate the rare earths we recycle back into our partner supply chain. I come from a multiple years background in recycling, particularly in the lithium-ion battery recycling industry, and joined Cyclic Materials almost 2 years ago now. Since then, we've grown quite significantly, and we're really expanding globally now. Cyclic Materials, as mentioned, is focused on the recovery of rare earth elements from waste. We take in various electronic wastes such as hard disk drives, speakers, headphones, electric motors, micromotors, anything that contains a rare earth permanent magnet, we would take in. And we use two technologies we developed to recover those materials. The first one we call MagCycle. It's a mechanical process that allows us to separate the magnet from the other metals contained in the waste stream. Historically, no one's ever been able to do that in the past economically without needing to use manual dismantling. We do this through a completely automated fashion. There's no heat. Again, there's no manual intervention. It's purely mechanical, purely automated. From that process, that isolated magnet that we get, we then put into our second technology, which we call Repure. It's a hydrometallurgical process that refines the magnet back into rare earth oxides, which are the main commodities that are used in magnet manufacturing. So, as mentioned, historically, this has never been able to be done before. And so we feel we are the only company in the world that has this technology that can actually economically do this in the Western world and provide additional value to recyclers out there today.
That's incredible. And it's a rare treat for us when we get to do, these sessions with not just Terra members, because you all started as one of our allied members, but
Yes,
here in the last, I guess, probably, 6 months, you all have earned your R2 certification, which
correct.
just
Yeah.
makes doing business with you for all of our allied or all our allied and all our certified members that much easier. So, congratulations on your continued success, growth, and as well as being certified.
Mhm.
Um, so, for our folks out there that, are in this business, they're collecting hard drives, they've got other, instances of these materials coming in their door, and if, had some hit or miss luck with in the past, getting some value out of these commodities, what is it that, working with you all can help them achieve?
Yeah, so we're really focused, I guess, on maybe I'll step back actually. Um, when it comes to these hard disk drives, for example, we take in all kinds, old, shredded, and even dismantled. We don't really care about the form factor. We care mostly about if the permanent magnet's in there and it's at a good concentration. We take that kind of analogy to also other waste streams. So when we look at like cell phones, for example, there's permanent magnets in here as well. There's permanent magnets in your speakers of the cell phone or in the haptic engines in there. And so historically, those were all going to scrap. We're working with some customers who can actually dismantle and further recover additional value from these streams that they bring in. So we're really trying to find ways to add additional value to the dismantling and recovery of electronic waste from various sources. Everyone takes these in, removes the battery, maybe some boards, but then there's an extra few pieces you can make some additional money on now too.
So perfect. That so as if they've been somewhat deconstructed, even shredded,
Yeah.
there is the option to get and harvest this material out of that level of waste.
Yeah, exactly. I think some older, I guess, previous ways of recycling magnets needed really clean, perfect magnets so they could use it for some from a reuse. We don't care if it's chipped, if it's broken, if it's rusted. We're refining it back into rare earth oxide. So if it's shredded and broken up in smaller pieces, it doesn't matter. We'll recover it through our process, and then we'll be able to recover the rare earths from it at the end of the day.
Wow, that is definitely a game changer. I guess I knew you kind of that you guys were recovering rare earths, but I didn't know it was from like shredded scrap. I mean, so
Yes.
that that once that data destruction requirement from our members and R2 and the stewards
Mhm.
folks has got they've if they've the customer has requested shredding,
Yeah.
they can still find a valuable downstream for this. That's a great.
Yeah, exactly. And we work with everyone from hyperscalers through to ITAD through to electronic recyclers. So whoever in that value chain is ready to give it up for material recovery, we work directly with them. So some of the ITADs who do the data destruction will work directly with to get the hard disk drives and recover the magnets from it. But then sometimes they send it to their electronics recycler who does maybe one step to remove certain pieces that they're good at, but then they still have that stream that's rich in rare earths, and we would take that from them as well.
Okay. So how long has this technology been mature? How long has it been kind of in the field?
Yeah, so Cyclic Materials, the company started in 2021. In 2023, we completed our piloting and deployed our demonstration scale, we call it. So it's one step up from pilot. It's something that we can run the material at a fairly commercial scale and start selling material. That's operating today in Kingston, Ontario, Canada. And we're currently in the stage of scaling to our full commercial scale. So that means we'll have a plant in Canada still, that hydromet process that recovers the rare earths from the separated magnet. And then we're also building our first full-scale commercial mag cycle facility in Arizona, uh, just outside of Phoenix. That will take in
Yeah, I was
25,000
just
tons of
there this
scrap.
weekend.
Yeah.
Could have gone by and seen it.
Yeah, exactly. Yeah. Yeah. So it's under construction now. It's planned on coming online next year. And it takes in 25,000 tons of electronic waste, motors, and separates out the magnet. We also recover value from the copper, aluminum, the steel, the circuit board in there as well. And
Mm,
so, yeah, we're really excited for that facility. And we're looking to source material for it today.
that's great. So with that, I mean, so as you get, are you kind of extremely focused on just the rare earths, or are you also? I mean, I see you're obviously processing the other material, but are you
Mhm.
downstreaming that then to other partners?
Yeah, so we produce those other metals still at a scrap quality, like we're not refining them further, but we are focused on streams that do contain the circuit boards that do contain high amounts of aluminum or copper, as we do generate a decent amount of value for ourselves by taking those streams, because we do get them to a decently high purity that we can recover a lot of value from them. So yeah, we're focused on uh, really finding material that has the rare earth magnets, but we're also looking at the other base metals in there as well for us to recover value from. And in some cases, if there's enough of the base metals, even without the magnets, we'll take it in as well as a side stream.
That's great. There's been a lot of discussion. Right now we've got an environment where tariffs are kind of a question mark.
Hmm.
The whole idea is kind of onshoring a lot of our, these kind of rare earth materials and securing a supply chain domestically for the
Hmm.
materials that we need. How important is that, as a part of what you all are doing to make sure that, there is not just local demand, but local supply?
Yeah, so if we look at, I guess not the waste side, but the new material side, when it comes to these rare earth magnets, China owns over 90% of the market. Over 60% of the mines are within China. Over 90% of the processing capacity to take that mining concentrate into usable raw materials is in China. And then the magnet manufacturing is also over 90% in China. So there is a significant geopolitical risk on these rare earth elements, as you only have a single source. And no one wants a single source, as the last month or a few months actually have shown. It really puts a lot of stress on your supply chains. And so being able to kind of provide domestic supply of this material is quite important for us. We see recycling as a way to sort of artificially inflate a country's raw material reserves. You know, some countries have no rare earths, but if you go recycle there, you can actually boost up their own production domestically. And so we see that we can play an important role in bringing domestic production back to North America, Canada, US, Mexico, and we also plan on deploying these technologies globally. So we'll have these two technologies in Europe eventually, and then Far East Asia, so that again locally you can start generating these rare earth elements that are so critical to all of our applications.
So, beyond kind of like hard drives and motors,
Mhm.
where in the scrap supply chain is this material going to come in the front door or back door of our, recycling partners?
Yeah, so there are a few different sources we identify, especially on the electronic waste side. Wireless headphones, like we use, all the speakers use a little rare earth magnet. A lot of them have some form of rare earth magnet in their charging cases as well to help them align for wireless charging. And so we take in streams like that, like wireless headphones. We need the batteries removed, but that's one stream we take in. But similarly, any form of speaker. So we take in if the batteries remove portable speakers that contains enough rare earths for us to recover, along with smaller components that are in laptops like speakers and again haptic devices or engines in cell phones as well. So those are some other electronic wastes that we've taken. But then we also, if we go a step further, we take in some much larger stuff as well. We take in MRI machines, we take in wind turbine generators, we take in full electric motors from vehicles. Really, the scrap contains rare earth magnet in any industry. We look to
Mhm.
source it.
Okay. Well, I'm just thinking one of our partners that we do business with is one of our sustainer members, which is,
Hmm.
they're not a recycler, they're not, providing product and service to our recycling members. They're a manufacturer. They make headsets like this.
Mhm.
So this is just
Yes.
kind of like your traditional corded set. They make the earbuds that you'll find, on airplanes or,
Hmm.
with the traditional wires. Do even those that older technology, do those have those
So
in them as
really,
well?
yeah, it really depends. So there's four real magnets out there. We're focused on three of them. Uh, there's a ferrite magnet. Everyone's seen those, the fridge magnets, but they're also contained in some electronics, like some headphones. Some cheaper headphones would use a ferrite magnet. But then there's alnico magnets, so the aluminum, nickel, cobalt magnets. There's samarium cobalt magnets. And then there's neodymium magnets. Neodymium magnets are our core focus. Those are when people talk about rare earth magnets, they're mainly talking about neodymium magnets. We recover value from all of them, but that's where the bread and butter is for us. Some speakers, like some headphones, like the smaller portable ones, those will typically use a neodymium magnet, and the reason is it has a higher efficiency for playback. And so, when you're worried about battery and sound, you really want to have the strongest magnet in there, which is a neodymium magnet. And so, depending on the device and its application, we'll choose the type of magnets that's in it. And so the higher end devices will typically always have neodymium magnets, and that's our core focus. But let's say those ones they give away for free on the airplane, those are probably not neodymium magnets. They're probably a little too expensive for for that application.
Yeah, I would think so. So, for a, e-scrapper, certified recycler that's, seeing this material come in, they're shredding drives. They've got, kind of that scrap box that they're collecting. Then once it gets full, they
Mhm.
send it downstream it to somebody. What is the kind of like economic advantage of sending it to you all that are harvesting the magnets versus those that are going to
Mhm.
be just harvesting the metal?
So there's a couple. If you have separated streams that you can guarantee that this is a product line that would be rare earth magnet containing, there's definitely a value add that we can. So, I mean, for reference, these if you look at neodymium as the main rare earth in neodymium magnets, there's about 30% in the magnet. Uh, that material today trades at $50,000 a ton for its pure form. So you can see that it's a very valuable material. And so we can actually return some additional value to the scrap stream. It's only used in small amounts. So
Right.
that bump up is there, but it's not going to triple your price, for example, because it's only 1 to 5% of the weight of a typical use case. But it's definitely there. The other the other benefit that we've seen from working with the partners on this is the fact that a lot of the times when you go to shred stuff with these magnets, they get stuck to the side of your shredder. And
Mm.
then you have to go in and scrape them out. It's a health and safety risk. It's downtime. And so being able to take streams from our partners that maybe we can provide that additional value and it makes sense for them economically, they don't have to do any further processing themselves. The value isn't necessarily just on the material stream, but also on your operations and being able to remove those magnets from making it to your shredders as well.
Interesting. So so for your hard drives, I imagine that would be make a mess. I mean, potentially, yeah, you can
Yeah.
still recover that material, but if it sits stuck along the side walls of your shredder,
Yeah.
it's not really doing anybody any good, potentially, damaging your these their operations by slowing them down a little
Yeah.
bit.
Exactly. And we actually developed a third technology to help with this. So we developed something we call the CC360. It takes in whole hard disk drives and all the magnets are in one corner. They're always in the same corner. And it cuts off that corner. It leaves the platter untouched. And so you can go
Mhm.
and shred that platter without the magnet making it through to the process. And so then that corner gets separated out and it gets sent to us for recovery. So that magnet containing corner is now a higher concentration magnet, which we like. And you don't have to deal with magnets making it through your process. And you can still ensure that the data is going to be destroyed in the way that you promised your customer as well, because the corner does not get, when you cut the corner, it doesn't touch the platter at all. And so it's something that we developed and patented, and we actually have it deployed at a partner site, Sims. And they take in the drives, they cut the corners off, they send us the corners, and they do the rest of their obligation on the data destruction side with the rest of the drive.
Oh, that's great. So it's real turnkey for,
Yes, yeah,
it's an education process for them, and then it's helping them, again, take a waste stream they might have been doing this much with, and just, again, every penny on every pound helps.
exactly, yeah, yeah, definitely, yeah.
So for you all, trying to bring this new technology to scale. I mean, obviously you're
Mhm,
building the facility in Phoenix, but it's, you know, how much material do you need to bring in order for
mhm.
this to be kind of successful for you guys?
Yeah, in Phoenix, that plant has a capacity of 25,000 tons of input. So again, that's not just hard disk drives. That's also the speakers. It's also electric motors. It's MRIs, wind turbine generators. It's all these scrap streams from all these different sources that go into this facility. Um, we see that as a first step. We plan on deploying multiple of these mag cycle facilities within a region. We deploy them in a spoke and hub model. So you have multiple mag cycles feed into a centralized repair process. So the spokes are the mag cycle that remove the magnet, and the hub is that repair process that refine the magnet back into rare earth oxides. Um, when we look at the market overall, there's I think over 43,000 tons a year of scrap in just the Southwest region um, that contains magnets that we could recover. And so um, that scale we're at, it's big, but it's also not the full market yet. And so we do see that there's a growth factor still there. Um,
Right.
sorry, the 43,000 is for the US, not the Southwest. Sorry, yeah. So
Okay.
and then in those scrap streams, there's varying percentage of magnets, so 1 to 5% typically. And so from there, then that recovered magnet would go to that repair facility. The first one we're building it takes in 500 tons per year of magnet. That's going to be in Canada, and then we'll build that and scale it further as the demand comes.
Okay. So I mean, one of the trickiest parts of anything that's in this space really is logistics. I mean, it's,
Yeah.
getting material in from, Virginia to
Hmm.
Phoenix or to Canada.
Hmm.
Is there a geographic limitation as to where the economic benefit kind of starts to fizzle?
Yeah. So right now, we do ship material from all over Canada and the US. Well, right now it goes to Canada, but eventually we're going to Arizona
Mhm.
later this year. Um, so far, because of the total value of the material, so if you think about hard disk drive, there's aluminum, there's circuit board, there's magnet, there's a lot of value in there. It's not that hard to ship across, but there are some other scrap streams that are maybe lower value, and you don't want to be shipping it that far. And so that's why we're looking at actually eventually doing that spoken hub model. So we'll have that mag site
Right.
facility in Arizona, but then we'll have one in the East Coast as well to help with that side of the US. Um, and then on top of it, with logistics, again, those magnets are only around 1 to 5% of the weight, and that's our core focus.
Right.
And so we deployed in a spoke hub model because once you remove that magnet, now you have 25,000 tons going down to a much smaller tonnage of magnet that then gets shipped to the centralized hydromet facility, the repure facility. So it really helps with ensuring that the logistics doesn't play as much of a cost for
Right.
us. But it definitely is a significant consideration for us.
So even if they had somebody had that machine that was cutting the corners off, I mean, even
Mhm.
it might be it's simple enough just to when they get a big enough even shippable box through like
Yeah.
FedEx or UPS or somebody that would be a would that be worth it, or would they need to do something that's more on the Gaylord scale?
Yeah, we typically work on truckload scales for that.
Okay.
Yeah. So we would look at filling Gaylor boxes until we have a truckload, then ship. At the same time, though, you are still minimizing overall logistics because uh, that corner is maybe 20 to 30% of the weight cut down. And so instead of shipping all of that hard disk drive that you would typically, you only ship that corner now. And so you can get through much more drives before you actually have to move the material. And so, from a perspective of the ITAD facility, they're able to work with their local sites for the rest of the drive, like they would typically, and then those corners would just be shipped to us, and so that logistic cost is minimized as well.
So now, you received the materials, you've processed them through your two-step process, you know, domestically. I mean, who's purchasing this material from you? I mean, what kind of devices then are these going back into to continue that circularity?
Yeah, it's an interesting question. As I mentioned, majority of the supply chains in China today, and so we're trying to be part of the solution and create an ex-China supply chain for this. And so today, we ship all of our rare earth oxides to our partner in France. So it does get exported from the US today, mainly because the supply chain hasn't built up yet. But there are many players coming who would take this material and eventually convert it back into magnets. It's a big focus for not just the community in Europe and North America, but also for the U.S. government in general to help drive this industry up. So there's lots of players coming in, um, and so eventually the idea is that this stays in the U.S. and I think we're just a step ahead of the rest of them in our scale up, which is never a bad thing, but it's actually probably a good thing because it'll help other companies come in and be able to source material locally as well. So
Right.
that's the goal. It'll eventually go to magnet suppliers within North America, but today it gets exported to France with our partner Solvay. And then on the other metals, we have partnerships with Glencore for the copper recycling and other metals with local players as well.
Right. Um, so, what kind of growth do you see in this industry here domestically and globally on the recovery of these rare earths? Now that you guys have a process that kind of makes it turnkey.
Yeah, well, we think it will grow quite significant. If you look at some regulation as well that's coming in, especially look at Europe, there's a CRMA coming in that will require about 25% minimum of these rare earth elements coming from recycled sources. And they're looking to ban the export of rare earth elements to other countries so that they recover it locally. And so with these changes and these focuses from the various regions on ensuring that they stay within the region and not get exported, I think it'll grow faster than we expect. There's already a lot of material out there to recycle. Now with our technology, we're able to recover it. Beforehand, it was kind of lost to waste.
I find it actually fascinating that,
Yeah,
the Europeans have kind of even before all of the tariffs had been looking at
yeah,
ways to kind of force feed their own domestic supply by
yeah,
not allowing these materials to be exported.
yeah.
So that's kind of that's a natural growth path for you all. Obviously, I can see why you're starting to work in France,
Mhm.
but do you see any kind of other similar type of initiatives around the globe where domestic supplies like this are trying to be brought back, or what's the future of that?
Yeah, I mean, I see. You know, I think one key thing that happened last month, China did an export ban on these magnets and rare earth elements. So the actual magnets go into components, the rare earth oxides and rare earth metals that go into making magnets, they put an export ban, particularly to the U.S. As a response to the tariffs. And that's kind of created a scramble for the entire supply chain outside of China. Everyone needs these either raw materials or magnets to make their components, and so we see everyone's looking at the fact that uh, they knew that there's this risk from having a single source, but now it's actually playing out that that risk is coming true, and it's now impacting their overall supply chains and their ability to make their products. And I think it's something that we'll see more of in the next couple months, as I know a lot of people had maybe a month to a quarter worth of inventory in their warehouses, and so their production
Mhm.
hasn't stopped yet. But if that export ban continues, uh, eventually they'll run out of material and won't be able to actually produce their products anymore. And so with a response like that, you see all the governments around the world taking note, saying, okay, we actually have to focus on our domestic supply chain more so than before. We have to become self-reliant, especially when it comes to these critical raw materials, because they're used in everything. It's not just hard disk drives, it's not just laptops, not just cars. It's in medical devices. To be honest, when we started recycling all these rare earth elements and we're trying to find different sources, the amount of applications that would just pop up from people reaching out to us were like, I didn't realize a magnet was in that thing. Why is there a magnet in that? And so they're more critical than people think or even know. And I think with what's going on today, geopolitically and globally, we'll see more responses from governments to help create a domestic supply chain and keep material in here for recycling as well, as that's a key part of domestic supply chain.
So then these materials then just sounds like supply and demand. Demand's going to remain high, supply is going to get smaller,
Hmm.
maybe domestically.
Exactly.
So the value of this material just potentially goes that much higher for everybody.
Yeah, yeah. That's the hopeful goal as well, is that the value stays high. But we'll see how it pans out. I think it's definitely something that's uh, ever changing, and
Yeah.
so I think 10 years ago or so, the rare earth prices were much higher too, and so they are quite volatile overall in the market. But it's definitely something that China sees as they can use to their advantage, and so. Uh, uh, yeah, I've kind of lost my train of thought on that one too. Yeah.
No, that's okay.
Sorry. Yeah.
Well, so where, are you guys going to be active with, going to trade shows with, we got several coming up. We got the eScrap, the ITAD Summit, the REMA, I think is just having theirs. Where
Yeah.
might we out there, run across you all and have a conversation?
Yeah, definitely. We actually are at REMA right now, which is happening
Yeah.
as we talk. But we typically go to eScrap, and we're looking at the ITAD Summit this year, so we'll probably be there. And we were at the eSummit last year, and we typically go to that. And so um, we're definitely out and about, both in the North American conferences, but also some of the European conferences we attend as well.
Okay, great. Well, any last thoughts that you want to leave us with about, where you all, play in the circular economy, working with you guys, what the value is, at the end of the day, why do we want to work with circular material, cyclic materials?
Yeah, I kind of just want to leave the thought of maybe think about where you might find magnets in your own scrap streams that come into your facilities. As again, we're here to add an extra downstream for yourselves, add additional value. We see a major piece of the puzzle is actually the e-waste collectors and the separators and segregators. As making sure that the stream is concentrated enough for recovery is important for us, and historically, no one's been touching it. And so looking deeper into finding partnerships that can actually create these streams is important. So I just want to put it out there for everyone to maybe think about what comes in their facilities. And if there's an additional value, please, if there's a rare earth streams that you think you can get additional value from, please reach out to us because we're happy to collaborate on those things.
Excellent. Well, as all of our Terra members should know, is that whenever they have a need to get in touch with anybody that's a fellow member and they haven't asked or they haven't looked at or can't find their membership directory, all they got to do is contact us. We'll send you one out immediately. We always keep it updated and ready for you whenever you request it. So, um, if so, contact myself. We'll send you out a fresh directory so you can talk with Sean and the entire team at Cyclic, and again, hopefully you'll find them at some of these upcoming trade shows and be able to do business with them. So we thank you, Sean and team, for not only being members, but for being our hosts and introducing us to some very interesting technology and a way for our members to, be more circular, be more sustainable, and put maybe a couple more shekels in their pockets. So with that, everybody, we will look forward to seeing you again on the third Thursday next month. More to come on our topic at the beginning of the month, so stay tuned. See you soon. Take care. Bye, Sean.
See you.
Bye, everybody.
Thanks.
Cyclic Materials is a clean tech, climate tech startup in the space of rare earth elements, and we are focusing on recycling of rare earth elements from end-of-life products as well as production of magnet materials. Rare earth elements are the key ingredients of rare earth magnets, and rare earth magnets are among the most strong magnets that we know, and we put them in many different applications that are critical for the energy transition and electrification of our society. Some examples of those applications are electric vehicles, traction motor, MRIs, and many other applications. Those magnets are mostly supplied from only one country, and what we are doing is we are recycling those magnets from end-of-life products to put them back into the application. Recycling of rare earth elements produces less than 40% of the carbon footprint. It consumes only 2% of the water, and it does not disturb soil. Cyclic Materials today is a startup, but we consider ourselves truly a global company. By end of 2026, we will be fully established and installed in North America, and our production of mixed rare earth oxide is expected to be 600 tons per year. And by end of 2030, we will be globally installed, and our production of mixed rare earth oxide, our key product, will be over 3,000 tons per year. This is good for our environment, and also it opens up a new source of material that the industry will appreciate.